Okay, today's video is on solving exponential equations, and we like to call this the look inside method. Please remember that we should be writing down the topic number right here. So whatever topic number we're on, make sure you write the topic number off on the side. Okay, so we call this the look inside method because we're gonna end up with a base and we're gonna end up with exponents. And when the bases are the same, like for example right here, I have these bases are the same but the exponents are different, right? But I know that these things are equal to each other. So if I know that a to the x is equal to a to the y, since the bottoms are the same and I know the two things are equal, then these two things up top must be the exact same thing. So if I have a to the x and it's equal to a to the y, since the bottoms are the same, then the tops must be the same as well. I can say just x equals y. And that's it's one of those things where we kind of look inside the actual exponents and match them up, okay? But this only works when the bases are the same. So for example, on this one, I have 2 to the x is equal to 2 to the fifth, right? Notice that the bottoms are the same. Since I know these two things are equal and the bottoms are the same, then that means the tops of these things must be the same. That must mean that this x must be the exact same thing as this 5. And since I'm solving for x and I know that x must be 5, I'm pretty much done. Okay. Some of these problems are going to be really easy, especially when the bases are the same. Then we can just say, oh, then the exponents must be the same and finish this out. Same thing here. I got 4 to the x plus 2 is equal to 4 to the 7th. I want you to notice that they're telling these two things are equal and the bases are the same. The 4 matches up with a 4. Then that must mean that the exponents must match up as well. The x plus 2 must be the same thing as the 7. So I can say x plus 2 must be equal to 7 in order for these to be the same. Except since I'm trying to solve for x, I can go ahead and get x by itself by subtracting by 2 on each side. And I get that x must be equal to 5 as well here. And you can always check it, right? If I take that 5 and I plug it back in, then this becomes 4 to the 5 plus 2, and 4 to the 5 plus 2 is the same thing as 4 to the 7th, which is exactly what we want. Okay, so you can always check your answers and just make sure that each side matches up. Now, this one is a little bit tricky. I'm sure some of you guys see it, but for those of you guys who don't, notice again that I have the bases are the same. The 8 must match up with the 8. That must mean that my exponents must match up as well. That means whatever's here must match up with whatever's here. Well, remember that whenever there is not a number listed on that exponent, we must assume that that exponent must be 1. So now that I know that the bases are the same, that means the exponents must be the same, then I can go ahead and say that 1 must be equal to 2x minus 5. And like we've done on the last ones, we're just going to go ahead and solve for x. So I'm going to add 5 to both sides. I get 6 is equal to 2x, and then we're going to divide both sides by 2. And that must mean 3 is equal to x. And as always, we can go ahead and check. All I'm going to do is I'm going to take that 3, I'm going to plug it back inside. That's 2 times 3, which is 6. And then 6 minus 5 is 1. And now I got a to the first is equal to a to the first. And we get this to work out. So 3 quick problems. These are really, really easy when the bases are the same. The problem is going to occur when the bases are not the same. So let me go ahead and write a little asterisk over here. And it says, in order to solve an exponential equation, you must have the same base on both sides. And for these problems, we do not. So this is where it gets a little bit trickier, but the concept is going to be the same. We're going to try to use the fact that these guys are similar enough to rewrite these numbers so that I do get the exact same base. So what you try to do, and it doesn't always work, but you try to get the bases the same. Right now, I know that the base on this side is a 4. Unfortunately, on the other side, the base is a 64, and the 4 does not match up with the 64. However, because I am working with 4, I'm going to rewrite this 64 so that it kind of looks like this. So I'm going to be multiplying by 4s and hope that I can get the number 64 to pop up. So let me show you exactly what I mean. I'm going to do this on the side. So I'm going to go ahead and put like a little squiggle here just so you know that this is kind of what I like to call side work. Okay, we're going to do this on the side. I'm going to mess around with that 64, and I'm going to try to get 64 by multiplying by 4s. So let's see. If I take 1 4, obviously 1 4 is not the same thing as 64. So let's get another 4. Now I have two 4s, right? I have a 4 times 4, and 4 times 4 is 16. That's still not 64, okay? So I'm going to try another 4. Now I have 4 times 4 times 4. Well, remember that the first two 4s gives me 16. And then when I go 16 times another 4, look at that, that gives me 64. What did I just figure out? I just figured out that it takes 3 of those 4s in order for me to get 64. That is to say, instead of writing it as 64, 64 is the exact same thing as 4 cubed. Why is that important? Well, because now instead of writing 4 to the x is equal to 64, I can write it as 4 to the x is equal to, remember, we just said that 64 is the exact same thing as 4 to the third power. So I'm going to write this as 4 to the third power. Why did I take all this time to write it like this? Well, because now I notice that my bases match up. The 4 does match up with the 4. That means my exponents must match up as well. I can say that x must be equal to 3. And we are done, okay? So there's really, really tricky stuff, right? And we're going to practice a lot of these. And we're going to, honestly, I can tell you the more you see these, the better you will get at them. But it's going to take a while for you to kind of understand what's going on. And there's all these little tricks to them. Like this next one is definitely tricky as well. I got 1/2 to the x power is equal to 16. So if you try to use the same kind of format, right, you'd say like, oh, 16, let me go ahead and multiply by 1/2. Unfortunately, 1/2 is not going to work. However, because this is 1/2, let me go ahead and do some side work here. Let me remind you of a property that we had before. And I know what you're going to do. You're going to say, how did you know to pick 2? Well, because 2 is on the bottom. But let me go ahead and write down what I want to say. So I'm going to write with 2 to the negative first power. Now remember what happens when you have a negative exponent. When you have a negative exponent, we can't use negative exponents, so we're going to move it, okay? Where am I going to move that to? I'm going to move that 2 to the bottom. That's the last lesson that we did. So that's the same thing as 2 to the first, and we're going to have a 1 on top, and 2 to the first is just 2. So what is it that we just figured out? I just figured out that this 1/2 right here is the exact same thing as 2 to the negative first power. So whatever number, if there's a 1 up here, okay, whatever number is down here, we're going to rewrite it as a negative exponent, all right? So this 1/2 is the exact same thing as 2 to the negative first. So let me replace this thing inside the inside the parentheses right here. Instead of writing 1/2, I'm going to write this as 2 to the negative first power. Okay, just kind of before I move on, let's just kind of prove to ourselves, is 2 to the negative first power the exact same thing as 1/2? Well, yeah, it would move to the bottom, and now you have 1/2, and 1/2 is exactly what we're looking for. Hey, please, please, please do not lose this x. I need to continue bringing down this x. Okay, why did I do all that? Well, because now I have 2 as a base. I take a look at my other number, that 16 does not have a base of 2. But I can do the trick now because I know 2 is my base. I can use my trick to try to go ahead and write 16 as a power of 2. So let me go ahead and start writing out these 2's. If I have 1 2, that is not 16. Okay. If I have another 2, 2 times 2, that's going to give me 4, and that is not 16. If I add another 2, if I should say if I multiply another 2, then that's going to be 2 times 2 times 2, which is the same thing as 4 times 2, and that's going to give me 8. And that's still not 16. If I multiply by another 2, then that's going to be like 8 times 2, and that is going to be 16. So how many 2's did it take for me to get to 16? It looks like it took 4 of those 2's. So instead of writing 16, I can write 16 is the same thing as 2 to the fourth power. Now I can finally, well, almost, I can almost start doing my look inside method, but I want you to notice that these 2's match up. The only thing that's really stopping me right now is I have an exponent to an exponent. We got to go back to our rules and say, hey, what happens when you have an exponent to an exponent? Remember, you're supposed to multiply those exponents. So this becomes 2 to the negative 1 times x is equal to 2 to the fourth. Negative 1 times x, that's negative x. Sorry, I said negative x is equal to 2 to the fourth. Now I can finally go ahead and say, hey, these 2's down here on the bottom match up. Therefore, these exponents up here must also match up. So I can say that negative x must be equal to positive 4. We're going to divide both sides by negative 1. I can say x is equal to 4. Now, I know what you're thinking. You're thinking like, whoa, there's a lot of stuff that happened there. And you're absolutely right. There is a lot of stuff that happened there. Again, like I said, you're going to see these problems over and over and over again. And the more you practice them, the more natural this look inside method is going to start occurring. Okay. But you really need to know your exponent rules in order for this to work. All right. So we've seen something like this, right? Now we're going to go ahead and do the exact same type of problem again. What did I tell you last time? I told you, hey, if you have a fraction, hopefully there's a 1 on top. There is. Then I know that this is going to be the same thing as 3 to the negative 1 power. So let me go ahead and write that on the side. That 1/3 is the exact same thing as 3 to the negative 1 power. And now I'm going to go ahead and start focusing on that 27. Okay, so before I do that, let me go ahead and just handle that 1 to the third. Remember, 1 to the third is the exact same thing as 3 to the negative first power x. So we're using this fact right here, just like we did it here. Instead of 1/2, it's 2 to the negative first power. Instead of 1/3, it's 3 to the negative first power. So you're going to see these patterns start developing, and you're going to get good at recognizing like, oh, this is the same thing as this. And that kind of gives us a hint as to where we're going to go with this next, right? I see that I have a 3 as a base. This 27 over here is not a 3. But I definitely can multiply enough 3's to get that 27. So let's see how am I going to get that 27 using these 3's. I'm going to go 3 times 3. And right now that is 9. That's not 27. I need another 3. So let me bring another 3. I'm going to multiply by another 3. 9 times 3, that is 27. So how many 3's did it take me to get to 27? It took me 3 3's. So I can say that 27 is the exact same thing as 3 to the third power. That means where I see that 27, which I see it right here, I'm going to replace it with 3 to the third power. Let me go ahead and do that right now. 27 is the exact same thing as 3 to the third power. And I also want you to notice that I still have this x plus 1 left over. So I'm going to go ahead and put the x plus 1 right here. Okay, I have powers to powers. And what do I do when I have a power to a power? I multiply. So on the first one, it's going to be 3 to the negative 1 times x. On the second one, it's going to be 3 to the, hey, I'm trying to take that 3 and multiply it by all of x plus 1. So I'm going to write it like this. I'm going to take that 3 and I'm going to multiply it by all of that x plus 1. It's important you write it like this because that forces you to distribute that 3, okay? On the left, I get 3 to the negative x power is equal to 3 to the, remember, we need to distribute this 3 now. That becomes 3x plus 3. Okay, now I see that I have the exact same base. This 3 matches up with this 3. Since the bases match up, then the exponents must match up. So I get to say that negative x is the same thing as 3x plus 3. So I write negative x is equal to 3x plus 3. Remember, we really struggled with this for a while. And so I'm going to go ahead and just kind of remind you of these steps. Once you get down to this step, we're going to get rid of the smaller x. And the smaller x is that negative x on the left. So let me get rid of that negative x. I'm going to get rid of it by adding x on each side. I know a lot of us are going to start freaking out because you're going to say, oh no, there's nothing left over there. Well, if there's nothing left, then that number is 0 is equal to 4x plus 3. Now I get to go ahead and subtract 3 on each side. I get negative 3 is equal to 4x. And then I'm going to divide both sides by 4. And I get that x is equal to negative 3 over 4. There is no way I was ever going to guess that, but it doesn't matter because we're able to solve this algebraically. Okay, let's move on to the last two problems. Obviously, these are going to be the tougher ones, okay? All right, man, I see that 1 over 625, and I know that that's going to be, I'm not even going to do that on the side, because hopefully you know by now that when you have it like this, I can rewrite this as 625 to the negative first power is equal to 5 to the x minus 3. Now, normally I would match it up with this one, except this is way bigger than this. So it looks like I'm going to be trying to break down that 625 to make it look like a 5, okay, instead of the opposite direction. Because 625 is the bigger number, that's the one I'm going to break down. So I want to get a bunch of 5s until I get to 625. So let me go ahead and do that work on the side. Let's see, first one. If I go 5 times 5, that's going to be 25. And that's nowhere near 625, so I'm definitely going to need another 5. So we're going to take those two 5s, we're going to multiply it by another 5. 25 times another 5, that is 125. That's closer, but it's not there yet. I'm trying to get to 625, so let me bring in another 5. I'm going to multiply it by another 5, and 125 times 5, that is 625, which is perfect. That's exactly what I'm looking for. How many 5s did it take to get to 625? It took 4 of them. So 625 is the exact same thing as 5 to the 4th power, which means I get to replace that 625 with 5 to the 4th. Instead of 625, I'm going to rewrite this as 5 to the 4th power. Don't forget that negative 1 on the outside is equal to 5 to the x minus 3. I got an exponent to an exponent, which means I need to multiply these things. That's going to be 5 to the 4 times negative 1 is equal to 5 to the x minus 3. That's 5 to the negative 4 is equal to 5 to the x minus 3. All right, I got these bases to match up. I know that this 5 matches up with this 5. That must mean that this negative 4 matches up with this x minus 3. I get to say that negative 4 is equal to x minus 3. And when we add 3 to both sides, I get x is equal to negative 1. All right, we're going to go down to the last one. Hey, on this one, I'm going to do it the wrong way on purpose because I think it's something that you guys might do. All right, so here's what I'm going to do. I'm going to take this. I noticed that 4 is the smaller of the two, right? Again, I'm doing this wrong the first time around, and I can already see what's going to happen, but I don't think you can. So let me go ahead and break this down. I have this 4 on the left. I'm going to try to make that 8 into a 4. But remember, you got to multiply by the same thing. So let's see. If I have a 4 and I multiply it by another 4, that's going to get me 16, and that's already over 8. This is not going to work, right? I can't change that 8 into 4s by using 4s. So what do we do now? Well, what we're going to end up doing is we're actually going to break down the 4 and we're going to break down the 8. What do I mean by break down the 4? Like a 4, what can make it into, what multiplies to 4? Well, if I went with 2s, 2 times 2, that would give me a 4, and that would match up with the 4 right there, right? So what am I saying? I'm saying that 4 is the same thing as 2 to the 2nd power. So when I see the 4, I'm going to replace it with 2 to the 2nd power. And don't forget, you still have that x plus 2. Well, what about the 8? Well, I'm going to break down the 8 too, right? But now that I change the 4 into 2s, I definitely can get an 8 using only 2s. Okay, so we're actually going to break down both of them since I wasn't just able to break down the 8 by itself. Okay, all right, so let's go with 2s for the 8. We're trying to get these to match. If I go 2 times 2, we just said earlier that that's going to be 4. This time I'm trying to get 8, so that 4 is not enough. And if I multiply it by another 2, then this does give me 8. And that's exactly what I'm trying to get. I'm trying to get that 8. How many 2's did it take me? Did I use in order to get an 8? I took 3 2's. So I'm going to say 8 is the exact same thing as 2 to the third power. So when I see that 8, I'm going to write it as 2 to the third power in parentheses. And remember, we still have this thing as an exponent outside. So on the outside of the exponent, I'm going to write it as to the 3x minus 1. Okay, remember when we have powers to powers, we multiply. And also remember that I'm taking 2 and I'm multiplying by all of x plus 2. And if I want to multiply these together, I need parentheses around this x plus 2. So this is going to be 2 to the 2 parentheses x plus 2. And on the other one, the exact same thing. I'm taking 3 and I'm multiplying it by 3x minus 1. I'm going to put that in parentheses. It's going to be 2 to the 3 parentheses 3x minus 1. So important we put those parentheses because that forces me to distribute. Now I can write this is going to distribute here and here. So I get 2 to the 2x plus 4 is equal to 2 to the same thing. This is going to distribute. I get 9x. And this is going to distribute, and I'm going to get minus 3. Now that I have the bases the same, the 2 matches up with the 2. I can get those exponents to be the same. 2x plus 4, 9x minus 3. So then I get to write 2x plus 4 is equal to 9x minus 3. And we start solving. So we get rid of the smaller x. So I'm going to subtract 2x on each side. 4 is equal to 7x minus 3. I'm going to add 3 on each side. 7 is equal to 7x. Divide both sides by 7. I know I'm going fast on this part, but hopefully the algebra is not what's messing you up. Okay, that takes care of the notes for today. As always, if you have any questions, please feel free to ask.